All right, is everybody good with number 2? We're okay? All right, let's check out 3. 3 looks like a lot of steps, but most of you did it right. I just showed like every single step. I did help some of you with 3 in Zoom yesterday or on Friday. Also just realized I didn't eat my breakfast. Sitting here staring me in the face. I'm gonna be hungry the whole period because it's staring at me. Or is it there? I just want you checking number 3. Yep, I'm doing number 4, 5, and 8. So just check number 3, make sure we're okay. And then I did go through and highlighted the sides that I changed. So just make sure once you pick a side, that's the only one you can change. Are y'all okay with 2 and 3? The ones on your test are not this many steps. There's one that's pretty easy, and then there's one that's like a medium level. Okay? All right, let's look at 4. I'm gonna zoom out and do it on my whiteboard. So number 4 asked you to prove that the cosine of theta plus 1 over the cosine of theta minus 1 equaled 1 plus secant theta over 1 minus secant theta. Which side do you guys want me to adjust and try to rewrite? Okay, you could do the left, you could do the right. It actually doesn't matter for this one because they look about equivalent in terms of difficulty, right? I did the right side with Kevin. Doesn't matter, you actually do this one the exact same way too. So if you choose to mess with the left-hand side, how do you rewrite cosine to look like secant? 1 over secant, it's just the reciprocal, right? I rewrote the right side. So what I did was I rewrote secant as 1 over cosine in the numerator and the denominator. And then we're leaving this side as is. Questions about the first step? I hope we're checking. Okay, how did y'all justify this first step? Good, very good. If you did not give me justifications, the highest grade you could get was a 70. And most of you got lower than that because you were also missing some work. So this is a reciprocal identity. Now from here, what did you guys do next? There's a couple different things you could have done. That's what I did. Kevin's a mini-me. Does that scare you, Kevin? It shouldn't scare you. He got rid of the denominator down here and up here. That's what you did too? Good. I think that's the easiest way. The other way you could have done it, people at home, you could have rewritten this 1 as cosine over cosine. But then that gives you a fraction divided by fraction, so then you'll have to multiply by the reciprocal. That way takes longer. So are you guys okay if I do it Grace and Kevin's way? People at home, y'all got to talk to me. Hello? Anybody? I think my speaker's working. They were talking to me earlier. Yeah, it's on. KJ, can you unmute?
Yes, ma'am.
Thank you. They done wasted 5 minutes of my life. Hey, I'm multiplying by cosine. I'm not going to baby y'all. Y'all got to unmute and ask me questions if you have them. Does everybody see how this is a binomial? So you have to multiply both terms by cosine, but watch what happens. What's 1 times cosine? Cosine. What is cosine times 1 over cosine? Just 1. And then in the denominator, same thing. I'm going to have to distribute this to both terms because it's a binomial. So 1 times cosine is cosine. Cosine times 1 over cosine is just 1, and it was minus 1. So now does this side match that side? So the justification I wrote, I think, was eliminate denominator or something like that. You also could have just said simplify. Does anybody want to see me get them with a common denominator and then multiply by the reciprocal? Are you raising your hand for that, or you have a question? Okay, hang on. Does anybody need to see me get a common denominator with top and bottom, subtract and add the fractions, and then divide them, multiply by the reciprocal? That's the longer way.
Miss Poole,
Huh? No. I mean, for this one, you could eliminate the denominator by just multiplying it because you had a whole number over here. If you already have a fraction, then you can't do that. You'll have to get a common denominator. Yeah. Yes, Prania.
never mind. You answered my question. I was just wondering, how did you know to multiply the cosine?
Yeah, so there was a whole number here. I am going to do it the other way because I have a lot of y'all asking questions, and then I'll answer your question. Okay, hold on to it. Write it down if you need to. So this way, I'm going to get a common denominator for these two so that I can add in the numerator and subtract in the denominator. So does everybody agree I can rewrite this 1 as cosine over cosine? And same thing down here, right? Okay, get a common denominator. So then does everybody agree in the numerator we're going to get cosine theta plus 1 all over cosine when you add those two fractions? And then in the denominator, we'll get cosine theta minus 1 all over cosine. And so then when you multiply by the reciprocal to divide these fractions, the cosines are going to end up canceling. And you'll get cosine theta plus 1 over cosine theta minus 1. So you can do it that way too, Maddox. Either way. Yes, ma'am.
And that was my question. That my brain that makes more sense.
Yeah, that's fine. So my 8-week kids, you guys remember what I told y'all last week, and my kids that are virtual that get on here every day. There are at least 2 or 3 ways to do every single one of these. Do it whichever way your brain works. As long as it is mathematically correct, you'll get it right. So on the test, for these couple of problems, I think I gave you 4 of these. I'm not just looking at what you put in Delta Math. I'm also looking at your paper to make sure that it is correct. So this test takes me a little bit longer to grade, so y'all got to give me a little bit of grace on it, okay?
When I did the other way,
Uh-huh.
I didn't show my recipe canceling the denominator.
Show your work. You're proving to somebody who maybe doesn't know as much math as you that these two things equal. So show your work. All right. Number 5. People at home, if you have a question, do what Prodnia did. Prodnia, extra credit. Unmute and ask it. 1 over 1 minus cotangent theta. But this stuff is actually not that bad. So I don't have time for some of y'all sitting here pouting like it's super hard. It's hot in here, I know. We're going to get this because it's really not bad. I think some of y'all are actually starting to like it, which means you're nerds like me. All right. Which side did you guys choose to adjust in this one?
The right side,
Good. Why the right side? That's very good.
because you can deal with sine and cosine from the cotangent.
KJ, I'm so proud of you. Extra credit, dude. Good job. All right. You cannot rewrite this side as tangents or cotangents easily. This takes a lot of work. You end up having to expand the fraction. And then you have to try to rewrite it as cotangents, tangents. Too much work. KJ said he sees cotangent here, and he knows he can write that as sines and cosines. So somebody else tell us, what is cotangent written as sines and cosines? What do I write? Good, girls. Y'all said that at the same time. Jinx. Cosine over sine. And remember, this is called a quotient identity because you are dividing two things. It's a quotient. All right. Let's use our knowledge of the last problem. There's two ways you can do this one. Look in your denominator. There's a whole number and then a fraction. So we could multiply by sign in top and bottom to get rid of this denominator. Or in the bottom, you could get a common denominator so you can subtract the fractions. Which way do y'all want me to do it? Common denominator? Okay, so they're saying they want to see common denominator again. So how can I rewrite 1 so that it has a denominator of sine? Sine over sine. So now if I subtract those fractions, does everybody agree I'm going to get 1 over sine minus cosine all over sine? That's fine, perfect. Right here, you could say common denominator. That star just looked crazy. Common denominator, that's fine. And then right here, how do I divide 1 by a fraction? What do I do? Multiply by the reciprocal. So you're going to do 1 times sine of theta over sine theta minus cosine theta, which is going to give us what we wanted to start with, right? Yep. So your justification for this one, you could say multiply fractions, divide fractions. You could just say simplify. I'm fine with any of those. Okay? Yes, ma'am.
I tried it that way, but then instead of doing 1 divided by sine or sine the bottom, I did 1 over sine minus cosine sine the reciprocal of sine.
Gotcha.
Yeah.
Yeah, so that probably tripped you up a little bit.
Yeah, and so then I just left it as cosine.
Okay. So when we're solving a trig equation, we're looking for all of the angles that make the equation a true statement.
So I was asking for like 6 solutions.
Yes.
Would you just be finding all 6 of the sine, cosine, cosine?
Mm-mm. Yep. It's just asking for the solution. I'll show you an example in a minute. What's different about these though, you're not doing inverse trig, you are doing inverse trig. Let me reword it. But it's not just the angle between negative pi over 2 and pi over 2. I want every single angle that could possibly work on the unit circle that would make this a true statement. I want all of the angles. Okay, so there's 2 ways you could write your answers. General form, you're reading off that worksheet. Yep. I gave him the wrong worksheet to make up something and it was, yeah. Anyways, all right, general form. You're going to give me the first 2 solutions, like from 0 to 2 pi. And then we're going to put something on the end of them that would work every single time. Okay. So, general form is just a general formula for the solutions. I'm going to put solutions because it's sometimes more than one. A general formula for the solutions you get that shows they repeat each period. It's going to be kind of, yep. So I'm going to give you an example underneath this because y'all are asking really good questions. I feel like we just need to see it. So for example, if I tell you to solve, let's do two sine theta equal to the square root of 3. You are solving. What do you think we're trying to find? What is our quote unquote variable? Theta, right? We're trying to find theta. We don't know what that angle is. That's what I want. What would you move first? Because we are solving an equation. You would divide the 2, right? Can you see this okay, Kevin, or do you need me to scoot it up? Okay. So they said in class you would divide the 2. I agree. So then we get sine of theta equals square root of 3 over 2. How do you get theta by itself? Okay, you would, so I heard you would want to try to get rid of the sine, right? What is the opposite of taking the sine? No, not the reciprocal. What is the opposite of taking the sine? Taking the sine. No, reciprocals are not, yes, inverse, good grace. Y'all talking about some reciprocals. Those are not opposites. You said inverse? Okay, good. I didn't hear you. We're taking the sine inverse. Now, I did not say find the inverse function. If we're finding the inverse function of sine, it's between negative pi over 2 and pi over 2, right? Hello? Yes? Y'all paying attention? I didn't say find the sine inverse. That would be just in quadrant 4 or 1. I said solve, which means we're finding all the angles that make this a true statement. So on the unit circle, one time around, what are the angles where the sine is square root of 3 over 2? Good, Kevin. Pi over 3 and 2 pi over 3. If you are my degrees people, 60 degrees and 120 degrees, and then you can convert it, okay? Now, hang on. That's from 0 to 2 pi. Yeah, 4 pi over 3 and 5 pi over 3 are in quadrant 3 and 4, so they're negative. But if you go all the way around again, back up here, 7 pi over 3 and 8 pi over 3, all the way back around again, it keeps going forever. Every time you circle around that unit circle, you can add 2 pi and it'll work, right? Why is that the case? Good, Kevin. Kevin said the unit circle will repeat for sine and cosine every 2 pi. So your general form solutions are theta equals pi over 3 plus 2 pi k. I'll tell you what k is in a minute. Write it down. And theta equals 2 pi over 3 plus 2 pi k. I don't think you've done general form in my class. Huh?
It was like general form.
Yeah, that's completely different though. Yep. So listen to me, people at home, because I feel like I can already see some of y'all's brows furrowing if y'all were here in person. Does everybody agree that the sine is square root of 3 over 2 positive at pi over 3 and 2 pi over 3? I need a yay or nay from my virtual.
Yes.
Okay, thank you, Sydney. So then every time, that's the first time around the unit circle. The second time I go around, you could add 2 pi. The third time I go around, you would add 2 pi more. Does everybody understand that? So general form, you just add on whatever the period is, and then you put a K. What do you think the K means? How many extra times you go around. Good. The K just represents how many times you go around. So if I said find it the 4th time around, be careful. What would you put in for K? Good, Kevin. 3. This is the first time around. So if we go around 4 times, that would be 3 more times. You could put in 3 right here and add it and figure out what exactly that angle was. Josh, you okay? Okay. I couldn't tell if you were confused or bored. Daniel, you okay? All right. People at home, are we okay?
Yes.
All right. So let's write down what K is really quick. And then that's all the notes I have, y'all. We just going to do some examples, make sure you're good. So K is a periodic integer that shows how many extra times you go around the unit circle. Let me move it so y'all can see at home. There we go. So it's a periodic integer that shows how many extra times you go around the unit circle. That's what the K represents. All right, I want to see who's really with me and knows their stuff. What if this said tangent inverse? What would your general form say at the end? Good, pi k, because the period of tangent is just pi. Do y'all remember that from unit 4? Okay, good. It repeats every 180 degrees, not 360. All right, so they could ask you for general form. They could also just ask you for the solutions on a specific interval. It's usually a lot easier if they just ask us for general form. Because the interval they could ask you for could be -2 pi all the way to +2 pi. And you'd have to tell me every single angle on that interval that makes that a true statement. You wouldn't even have to give me, yes, you could give me 3. Are you guys okay with the notes for solving trig equations? We are solving now, so you're trying to find the angle. You're trying to get theta by itself. Is everybody okay? Kev, you okay, Ben? What you trying to get, that periodic integer part or the top part? You're good? Okay. All right, let's just do examples. People at home, we ready? Maybe?
Yes.
Awesome. Sydney, extra credit just because you don't let me talk to myself. I appreciate that. All right. Example 2. For all of these, I want us to practice giving a general formula. General. I can't spell today. Give a general form and solutions on the interval. What interval would y'all like to practice? Do we just want to do 0 to 2 pi? Okay. How about I change the interval each time so we can practice different ones? Does that sound fair? Okay, I feel like that will prepare you for your test. All right, so for the first one, I want the general form and I also want the solutions from 0 to 2 pi, so just the first time around. So we'll start off kind of easy. Then we're gonna solve, my pen's not working. Okay. We're going to solve for -3 secant theta minus 1 equals 5. All right, so remember for these, you are solving. So what would we move first to get theta by itself? Good, +1. What's 5 plus 1? Great. So does everybody agree we get -3 secant theta equals 6? Okay, what would you do next to get theta by itself? Divide the -3. And so then we get secant theta equals -2. We need to get just theta, not secant of theta, just theta. So to get just theta, what's the opposite of taking the secant? Secant inverse. So theta is going to be the secant inverse of -2. I didn't say find the inverse function. I said solve. So I want all the angles where this happens. So this does kind of relate to what we did at the beginning of the unit though. We don't know a trick for secant, but what do we know about secant? Reciprocal of cosine. So does everybody agree we can really just find the cosine inverse of -1/2? I flipped -2. Y'all okay? I'm worried about some of y'all because you're really quiet. I don't know if that means we're confused or I don't know. Y'all talk to me if you got any questions. So I want you to think about it. I'm not going to give you the answer right away. Where on the unit circle is the cosine -1/2? Nobody blurt it out. Think about it. Look at my hand triggers. What are we getting? 2 pi over 3 and what? Let me ask you this question. Y'all have got to learn this unit circle for real. That's okay. No, I'm going to ask, they're quiet though. I'm going to ask them a question. What 2 quadrants is the x value, the cosine, going to be negative in? 2, good, 2 and 3. So we should know from our hand trick that the cosine has one finger at this third angle, right? So that angle is pi over 3, but I need it in quadrants 2 and 3 because that's where it's going to be negative. So the pi over 3 angle in quadrant 2 is 2 pi over 3. What's the pi over 3 angle in quadrant 4? 4 pi over 3. Not 4, 3, I'm sorry. I meant 3. It's negative in 2 and 3. So these are my 2 solutions from 0 to 2 pi. How would you write the general form? Okay, 2 pi over 3 plus 2 pi k. Theta equals, because it's a formula. You leave off the theta equals, I'm taking points off. And then theta equals, what would the other one be? 4 pi over 3 plus 2 pi k. You could put the 2 pi k first, but you'll always see the solution the first time around, and then they'll add on the period. But I mean, technically adding is commutative. This is just like a constant, so they'll always put that in the back. Yes. Yeah. So you can't write that as one formula. Here's why. From 2 pi over 3, that's in quadrant 2. To get to quadrant 3, that's just 90 degrees. So that would be like writing pi over 2k, But then in quadrant 3, if you go 90 degrees, that's just quadrant 4, and that's not a solution. Does that make sense? So you can't just write one of them, you have to write both of them. Good question, Taryn. All right, I'm gonna keep going. If you have a question at home, please just unmute and ask me. I'm wondering how many more we think we need. What y'all think, like 2 more? It's not bad. I think I can do, maybe I'll just do 2 more. Y'all let me know how you're feeling. Let's do this one first. 2 cosine squared theta plus cosine theta minus 1. This is what we're doing Thursday again too. I'm just gonna step it up on Thursday. Ooh, let's do what Kendall said earlier. Find the solutions on the interval -pi to pi. That way you can practice different intervals. I love equations like this because it's a quadratic. I'm grinning under my mask. Math 2 is one of my favorite classes to teach. How do we solve a quadratic, people at home? What's the fastest way to solve a quadratic? They got to answer. I said people at home. We'll wait. They're going to hate me this week, especially today because I didn't take my medicine. I have no filter. Hello? How do we solve a quadratic? I'm going to make y'all participate.
Do we have to factor first?
Good, KJ, you got a factor. There we go. So everybody look, remember when I told you at the beginning of the semester, I hope you know how to factor because we're about to factor with sines and cosines. Here we are. Let's review how to factor trinomials. What are my factors of 2? 2 and 1. So 2, I'm going to leave some space, and then 1. You don't have to put the 1 out front if you don't want to, right? It's understood? Okay. Now, what are the 2 factors of cosine squared? Cosine and cosine. Good, Kevin. Think about x squared. You would split it up x and x, right? So cosine squared, you split it up cosine and cosine. Now, what's the other number or value I'll look at for the back? Good, the -1. Look at that 1 first. I'm making sure you were taught how to factor right. This is why those of you that learn slide and divide, I hate that ish. You cannot slide and divide with cosines and sines. Good, you don't need to know. A corny way that also just mathematically does not make sense that teachers teach because they don't think kids can handle this. It's my opinion. Y'all can handle it. I don't ever teach slide and divide, not even to math 1 kids. You're going to do it the right way. What are the factors of 1? 1 and 1. So I gave you an easy one. Now look, this is what Kevin was saying. It's negative, which means my sign should be different. Does everybody agree? Because a positive times a negative is what gives us a negative. But I want a positive cosine in the middle. That's what I'm trying to get. So where should the positive go so that we get a positive cosine? Good, where it's multiplied by the 2, and this one would be negative. How can you always check yourself with factoring? Foil it back out real quick and make sure it works. So I've got 2 cosine squared, that works, plus 2 cosine, that works, minus 1 cosine. So what's 2 cosine minus 1 cosine? Positive 1 cosine, and then minus 1. So these are my 2 factors. Everybody okay with how we factored that? Okay, so now what do you do to solve? Look at these smart children. Set them both equal to 0. There we go. 2 cosine minus 1 equals 0, and then cosine theta plus 1 equals 0. Y'all are so smart. All right, so does everybody agree this first one will end up being cosine equals 1/2? Because you'll add the 1 and divide the 2. You'll add the 1 over. Yep, you're good. And then this one will end up being cosine theta equals -1. Okay. So how do I get rid of the cosine just to find the angle? Inverse cosine, good. Cosine inverse of a half, which we already just did, so no one blurt out anything crazy. And then cosine inverse of -1. So this is where this one is going to be tricky. I don't want 0 to 2 pi. I want -pi to pi. So I'm going to draw a picture for some of you at home, just so we're all on the same page. -pi is these angles all down here, but they are negative. Does everybody agree? This got to be a cute little sketch. Maybe I can draw when I'm off my medicine. We got to find out. And then positive pi is these angles right here. So technically, I still want the whole unit circle, right? But I want the negative angles and the positive angles because my interval is from -pi to pi. The top angles won't change. The bottom ones are just going to be the negative version of the top. So are you guys okay if we just find the top angles first? And then we'll make them negative for the bottom, maybe? Okay. All right, where in the top 2 angles is the cosine positive 1/2? No, quit saying pi over 6. I know, you keep flipping them. 1 finger above, it's the 3rd angle. It is pi over 3 or 60 degrees. Now, can we have a positive 1/2 in quadrant 2 for the cosine? Nope, the x's in quadrant 2 are negative. So does everybody agree that the positive angle is just in quadrant 1? I said quadrant, Lord Jesus. Quadrant 1 and it's pi over 3. Huh? No. What were you saying? Cosine is positive in quadrant 1, and then what's the other quadrant? That the x's are positive. 4, good. So what's going to be the negative angle of this in quadrant 4? Just negative pi over 3. Huh? Are you moving ahead? Okay. All right, where on the unit circle is the cosine -1? Where is the x value -1? Right here at pi, right? And also at -pi. Good, Maddox. So for this one, we're going to get -pi and pi. So these are your 4 answers. Yes, you need all 4 of them. That also means you have to write 4. Do you? Good, Kevin. Extra credit. You actually only need 3 general solutions. Remember, general solutions are from 0 to 2 pi. So this is a challenging one. I'm just going to write it. People at home, ask me a question if you got it. General solutions are pi to 2 pi. So your general solutions, Lord Jesus, should have taken the medicine, are pi over 3 plus 2 pi k, because the period of cosine is 2 pi, right? Okay. Then we also need 5 pi over 3. Somebody tell me why I chose 5 pi over 3 instead of -pi over 3. General solutions are from 0 to 2 pi. Good. So you would need 5 pi over 3. That's the quadrant 4 one. And then Kevin said you would just need pi because technically -pi and pi are the exact same point. But for general solutions, we want from 0 to 2 pi. So these are your 3 general solutions. That's the part where y'all tend to mess up is the general solutions. Uh-huh. Because you'll just write this plus 2 pi k, but general solutions are from 0 to 2 pi. And then you add on. They're not negative. All right, I'm gonna keep moving unless somebody at home unmutes. I really want them to ask me questions. I miss y'all. Ask questions. All right, let's do one more. This one's a little bit different, and then I'm gonna give y'all homework time. And for this one, just for the sake of practice, let's go back to 0 to 2 pi, okay? So the interval I want you to use for this one is 0 to 2 pi. People always mess up on this one, so let's see what we got. What would we do first? Very good. Everybody listen very carefully. This is what you do not do. Do not do this. You are not distributing the tangent. That is not what we are doing. We are taking the tangent of this entire argument. Does everybody see that? It's like when we did logs and it was an argument. So you're not distributing. You're taking the tangent of this entire argument. So what is the opposite of taking the tangent? To move it to the other side, we're going to do the tan inverse. So everybody watch. Now we just have pi over 2 minus 2 theta equals the tangent inverse of 1. Did I confuse anybody, or y'all are okay with this one? To me, I actually think these are a little bit easier. Why is the 2 pi up here? Because 0 and 2 pi are the exact same point. So I want you to include 0 and not 2 pi. Good question. But then you'd just be writing like the same solution twice. Is everybody okay with step 1? Okay. Now, I'll make sure we're all paying attention. When you take the tangent inverse at the beginning, I hate when they call me when I'm teaching. I'm not answering. When you take the tangent inverse at the beginning, I did. It's going to drive me nuts. When we take the tangent inverse at the beginning, your inverse function rules apply. These get tricky. So I just want the one angle where the tangent of inverse is 1, oh my God, between negative pi over 2 and pi over 2. I'm not answering it. Listen to me. Between negative pi over 2 and pi over 2, where is the tangent 1? In quadrant 4 or 1? Which one? Quadrant 1, because it's positive. And then where are the x and y the exact same, people at home? Where's the tangent 1? People at home, where's the tangent 1? Is she calls
Over 4.
Thank you, pi over 4. Good. Thanks, KJ. Extra credit. My boy's getting it today. Pi over 2 minus 2 theta is just going to be equal to pi over 4. What are we trying to solve for? Theta. So what would I move next? Good. How would you move the pi over 2? Subtract it. Good. Negative 2 theta equals pi over 4 minus pi over 2. Okay, what is pi over 4 minus pi over 2? Be careful, other one. Oh, y'all in these fractions. Pi over 4 minus 2 pi over 4, if you get a common denominator, is what? Negative pi over 4. There we go. It's okay. Kevin, you okay? Okay. How would I get rid of the negative 2 over here? Divide it. Good. Can I divide two fractions? No. So we're going to multiply by the reciprocal. Negative pi over 4 times negative 1/2, which is going to give us what? Negative pi over 8. That is your solution.
Wait, isn't it positive?
Oh, yes, thank you. Taryn told me negative. Can you let him in? I'm going to keep teaching though. I'm sure it's because they called his room trying to get up with me because I didn't answer my phone. Stay with me. Does everybody agree it's pi over 8? What would the general form solution be? Look at me, not Mr. Polk. They called you because they're trying to get up with me because I hung up on them because I'm in the middle of teaching. I'm not mad at you. They're killing me today. All right. What's the general form solution? Good, Maddox. People at home, y'all can unmute and get extra credit too. Y'all gonna be the ones talking about some. Can you give me a point? Pi over 8 plus pi k, because what was the original function? Tangent, which has a period of pi. Do we feel like we can do our homework? Okay. I'm going to make it even easier. People at home, if you have a question, hang tight for a second. I'm going to make it even easier. The top section says write a general form and then list. I think I changed it to say 4. That's an old worksheet. And says list 4 solutions. You don't even need to do that. Just give me the general form for the top. For the bottom, it only asks for the solutions from 0 to 2 pi. So I don't need the general form for those. Okay? All right, I did change the worksheet a little bit, my week A kids. Number 9 and number 10 are gonna be different. So just make sure you get the right ones off of Canvas. If you have any questions, stay up here and ask them.